Hi, I'm Lakshya Jain and this is my video for Maths Trial 2. So let's get started. Okay, so the question to us is that we need to find the Laplacian of the function sin 2t. Right. Now, by definition, Laplacian of any function ft is given to us as the integral with limits 0 to infinity e raised to power minus st multiplied by the function ft dt, where s is actually a complex variable and it is greater than 0. Okay, so for the question, the function ft is given to us as sin 2t. Okay, so on substituting the limit, the Laplacian of the function ft, that is for this question Laplacian of sin 2t is equal to an integral with limits from 0 to infinity e raised to power minus st sin 2t dt. Okay, I'm gonna name the indefinite integral for this case, that is the integral e raised to power minus st sin 2t as I. So we're gonna first solve this the indefinite integral, and then we're gonna put the limits from 0 to infinity after solving this indefinite integral. So for solving this integral, we have to use integration by parts. So I'm gonna name sin 2t as my first function and e raised to power minus st as my second function. So on applying integration by parts, for the first term we're going to leave the first function as it is, multiplied by the integral of the second function minus integral the derivative of the first function, that is sin 2t for this case, into the integral of the second function, this whole and dt. So the integral of e raised to power minus st is e raised to power minus st upon minus s. So e raised to power minus st upon minus s sin 2t. And for this term, the derivative of sin 2t is 2 cos 2t, and integral of e raised to power minus st is e raised to power minus st divided by minus s dt as a note here. So this gives us e raised to power minus st upon minus s sin 2t plus 2 upon s. Since the integral is with respect to t, we can take out s, which acts as a constant for this integral, cos 2t e raised to power minus st dt. Now this integral can be solved once again by using integration by parts. So I'm going to use that. I'm going to once again take this trigonometric function as my first function and this exponential as my second function, and I'm going to name this integral as I2, that is cos 2t e raised to power minus st dt. So let's solve it using integration by parts and cos 2t as first function and e raised to power minus st as my second function. So first function as it is for the first term, multiplied by the integral of the second, minus the derivative of the first function cos 2t, and multiplied by the integral of the second function dt and this whole dt. So the first term yields us e raised to minus st upon minus s cos 2t. For the second term, the derivative of cos 2t is minus 2 sin 2t. Integral of e raised to minus st is e raised to power minus st divided by minus s and dt here. So this gives us e raised to minus st upon minus s cos 2t and minus 2 upon s integral sin 2t e raised to power minus st dt. This is our I2, integral I2. Now on carefully examining this integral, sin2t into e raised to power minus st dt. This is the same integral I, right? So I'm gonna put I here instead of this integral. So I2 therefore yields us e raised to power minus st upon minus divided by minus s cos 2t minus 2 upon s I, right? So this, now I'm gonna substitute the value of I2 in this equation. Okay, so let's substitute. I is equal to sin 2t e raised to minus st upon minus s plus 2 upon s I'm going to substitute the value of I2 here, and the value of I2 was e raised to power minus st upon minus s cos 2t minus 2 divided by s I. Okay, so I'm going to take the I term from the RHS and move it to LHS, so which yields us I plus 4 upon s square I. Since 2 divided by s was common, this get multiplied by 2 by s, that was the coefficient of I, and on taking to LHS we get this, and this is equal to sin 2t e raised to the power minus st upon minus s minus 2 by s square e raised to the power minus st cos 2t. Okay, so taking I common, 1 divided by 4, 1 plus 4 by s square, this is equal to minus, I'm taking out e raised to power minus st upon s common, this gives us sin 2t plus 2 upon s cos 2t. Okay, now this can be written as e raised to minus st upon minus s sin 2t minus e raised to minus st upon s square cos 2t, and I1 plus this is s square plus 4 divided by s square. Now I gives us e raised to minus st sin 2t divided by minus s minus 2 e raised to minus st cos 2t divided by s square divided by s square plus 4 on s square. Now let's put the limits in order to find the Laplacian. The limits were from 0 to infinity, right? So now when we put the limits from 0 to infinity, this denominator that we have, this is a constant, so it gets taken out, so is 1 upon s square plus 4, this square comes right above here, and these terms, that is e raised to minus st sin 2t upon minus s, this goes from limit 0 to infinity, and similarly another term having t as a variable goes from 0 to infinity, and this actually is a Laplacian of sin 2t. Okay, so now consider when we put t to infinity, when t approaches to infinity, this term, now e raised to minus st, it rapidly decays and approaches to 0 as t tends to infinity. But the function sine 2t, it basically oscillates between 1 and -1. So the net result is that this entire term, the sine to t, basically the sine to t gets bounded by an envelope thing due to e raised to minus st decay, and the ultimate result is that when t tends to infinity, this term tends to 0, right? And this is evident by the fact if we draw the graph. So the graph comes something like this, right? So basically the function of sine gets enveloped between the graph of e raised to minus st. So when we put t tends to infinity, this entire term becomes 0, and same is the case for cos 2t, since cos 2t also oscillates between 1 and -1. When we put when t approaches infinity, this term also approaches 0. So when we put our limits, for infinity it is 0, but for the first term, when we put t as 0, then also it yields us 0 as sine 2t becomes 0. For the second term, as it tends to infinity, this becomes 0, and sorry, it's the minus sign here, and minus cos, when we put 0, it gives us 2 upon s square itself. So this yields us s square upon s square is 4, and minus minus gives us plus 2 upon s square. S square and s square gets cancelled, and finally the Laplacian of a function ft, that is the Laplacian of sine 2t in our case, is twice 2 divided by s square 4, and this is our answer.